answer in the end of the presentation. Okay, sharing my screen. Just let me know, and it is okay for you.
It looks all good to me.
Yeah,
Is it okay?
yeah,
Okay, good. So I'm Tiago, and we start talking about Impararia, Dassault Systems, and Productization, how we can add value for your business too. So the agenda that we prepare for today, we prepare five items for you guys. So I will talk a little bit about our company and Dassault Systems and our partnership. We'll bring you some concepts about the productization on the AEC industry, and we will bring a customer case, how we add value for a specific customer, and how we can add value to your business, our solution to do that, and at the end, some questions and some takeaways. Presenting, I will present my colleagues. So I have Arnaud. Arnaud is graduate in engineering. He is actually CAD PLM consultant at Impararia. He worked the last 10 years as in the environment of CAD and PLM consultancy. So I am BIM project manager. I'm graduating in telecommunication engineer, and I work at Impararia as BIM manager and project manager for the industry of architecture and engineering and construction. And we have Karun with us. Karun is from Dassault Systèmes. Karun has a master's in industrial engineering, and he has 25-year experience in software business consulting in domains of engineering, manufacturing, and life cycle and operations. So we are the guys that are going to show you a little bit about our experience, our product, and our companies. Talking a little bit about Impararia and Dassault Systems. So Impararia, we are a business consulting company which develop on business requirements for our clients. We follow the industry standards such as BIM, Building Smart, IFC, ISO 19650, and all the other standards in the industry. Just everything aligned with the customer experience. We have 15 to 20 years old of experience on that industry. So, and we do this basically with three core activities. We work as integration. We integrate products that you are using. For example, we can integrate databases. We can even resell licensing from our partners. We work as base modeling. So we have designers in our team with automation knowledge who can design parameterized models based on your requirements and your rules in an automatic way in a high level of detail. And we have an internal team of research and development that takes care of researching new technologies, developing new technologies for the clients, applications, add-ons, and make the connection between new technologies and what we are using now to provide you the best solutions for to achieve the best results for your business. Impararia has his roots on the aerospace and defense industry, working as product lifecycle manager products, but we are bringing this knowledge, the experience for the architecture and engineering in architecture and engineering construction industry. But we already have some projects on these industries. As you can see, we have a lot of clients with different kind of clients for this industry. So we are working very hard on aerospace, AEC, and infrastructure manufacturing industries. So we are developing this technology and business to these companies. I will call we'll call Karun to talk a little bit about Dassault, that is our partner.
Mm-hmm. Thank you, Tiago. So I just wanted to briefly introduce Dassault Systèmes, the company to which I'm working. So Dassault Systèmes is the 3D experience company. We are a purpose-driven company. Sustainability is at the heart of everything we do. We want to combine the science and technology with art to harmonize product, nature, and life. So that's at the core of everything that we do internally as well as for our customers. So we are a large company, 400 billion annual revenue euros, and a healthy operating margin. And we are majority shareholder by the Dassault family. We are 20,000 people plus strong. We are constantly acquiring new companies worldwide, and it's a very diverse employee base that we have spread over 133 countries. We invest significantly in R&D, so a lot of new development, new enhancements. We have over 69 R&D labs worldwide. We have more than 12,000 partners. So Impararia is one of our key partners, and it's one of the key partners, especially in the AEC industry. So partners providing software, technology, services, software development, education, and so on. A variety of partners helping customers maximize value from our software solutions. And we have more than almost 300,000 customers now. The slides it's not been updated. We have crossed 300,000 customers since across various industries, from automotive, aerospace to cities and construction industry and life sciences. So that's our company key figures in a nutshell. Tiago, can you go to the next slide? Yeah. So our company, Dassault Systems, is a spin-off from Dassault Aviation. So our roots are in the aerospace industry and automotive industry. We have worked with leaders like Boeing, Toyota, Airbus for several decades now. So that has really helped us penetrate the building product manufacturer space. We have almost a 25% market share of building product manufacturers using our software. The last decade or so, we have taken this experience and this expertise from the manufacturing industry, from the manufacturing world, and started applying them to infrastructure, so buildings, cities, energy industries. So in the construction industry specifically, we have a number of customers from architects, engineering companies, general contractors, infrastructure companies up to cities. And we also provide solutions for a number of users, from owner-operators to general contractors to even end users. The Home by Me solution that you see on the top left, this is our solution to allow individual citizens to develop their own homes and kitchens and so on. And we have tens of thousands of users using this solution to develop their own homes worldwide. So we are helping, as I mentioned, building product manufacturers both on the engineering and the manufacturing side. And our goal is to take this experience that we have in the manufacturing world and bring that to building product manufacturers and the construction industry as a whole. So with that, I turn it back to Tiago.
Okay, Karum, thank you. So moving forward, let's go to the concepts of productization. So I will start with the first question is, what is productization? And to explore this concept, I am bringing to you a few items to illustrate this. So first of all, modularization is a key concept in productization. How can I explain this? So when we talk about modularization in productization, we talk about the small models, different models, as you can see here, these models that can have variants. And even for this part of the hydro model, as this wall, we can have variant models. And these variant models that can build different products, can modulate different products. And the key for this, when you have these models, these small models, you have to have some interface, standardized interface to be able to connect these models. So when you have these models and this interface standardized, you can connect all of them in different ways, in different variants. So and this interface, you're talking about mechanical attachment, communication, transfer of electrical, gas, or fluid flow. So you have to have those interface standardized to be able to connect all the models and make as diverse as possible. in the building of the function block. An example, we can decompose a building, for example, in different product lines where we can have different models connected with those standardized interface, the connection between the models. So we can decompose this building, for example, in different models, like the partitioning part, the finishing, the HVAC systems. So when you decompose these models and when we have these basic building blocks, we have this basic model digitalized, we can use them to make different designs. So it comes with the next item. So we have to digitalize each basic building block within a model, including the physical process of the development. We call this a virtual twin. So this is standardization of this interface and this digitalization of the physical process. We can have this virtual twin. I will give you an example. For example, a digital twin for a model and can go in the highest level of detail. As for example, this model, we have even the screws and in the model that are presenting in this level of detail. So you can navigate the model. This presentation, this video is showing directly in our platform. So you can have this interface standardized in the model, and you can see all the model itself with all the connections made. You can navigate in the model, go into, walk through the model, go into the very, very high level of details. So you can see everything is modeled in digital. This is an example of a model with high level details. And with this level of detail, you can achieve, for example, automatic list of materials for the supply chain. And you can, after you can use like generative design. I will show you in the next slides a little bit about this. So this is an example of a high level detail model for a model. We can have even the process itself digitalized. So digitalize the model and you can digitalize the process. When you do this, you have this virtual twin that we are calling, so you can analyze. In this example, we have this whole production line digitalized. Within that, we can analyze the process itself, the quality of the process, the time of the process, evaluate the time evaluation, the production evaluation, the waste evaluation. So this is a production line. You see they were producing here a wall and everything is connected, everything digitalized, so you can measure all your process and get feedbacks. So even for the automation part as the human part of the process. You see, you can have the time of work for each step. In the end, you can have information about the whole factory, the whole product, the time of the product, the quality, and you can evaluate even the performance with KPIs, the people performance, and the energy consumption or the waste that you did during the process, because you have a digitalized process where you can simulate everything before start doing, and after that you can bring the information from your process in the field to your digital virtual twin and improve. Another item that I bring is the productization is about the process. It's about the process standardization, automation, and control. And not only the production process. Here I came with an example of the planning process. If when you plan to build the product, the house in the field, you can simulate this construction before in digital. So if you have the digital twin, the virtual twin, you can simulate all the process of construction, the construction itself and the assembly itself, everything in the computer before going to the field. So this is for deep planning. So you have the schedule and you can simulate all the operations. I know that you guys from the modular home builders, you do a lot of icing. You do this kind of service with the to transport the houses and everything. So you can simulate everything when you have this digital twin. Not only the digital planning itself, but you can even have information and you can simulate and plan the installation itself. So this is an example when we are set up in and the scale before, of course, and after we can go to defining the operations of the plant in the field. So we are planning in low level detail here, so you can measure after, you can have information about how it was, and you can retroalimentate the process to get. So this is the planning. We are planning the wall operation here. So the estimate date, the duration, how many resources we're gonna use to make this operation. And I will definitely go faster here. And in the end, you can have more information about how was the process itself. Don't let me go faster. Other item I bring to illustrate for you is exactly the incorporation of real world feedbacks from the field and the updates to the virtual twin. So based on what happens on site. So we can you can capture this learning that is the key component for the productization, for optimization of your process of construction. So you can capture the learning and make it repeatable. You will not make the same mistake again. So here I bring an example. This component here, for example, the guys in the field, they identify that there's a problem with the model. This component is higher than it should be. So we have to update the model. And once you update the component, you are updating everything that comes with the component, the material that the component use, even the ladders, even the shoring tower. So we need the shoring tower to put this resource. So maybe we have to change all this these materials to make this component available to install this component. And when you change the model, everything is connected. You are changing everything about the installation of this component. And for the next project, the next construction, the next model, probably you will not happen this same mistake because you are incorporating, you are capturing the learning and incorporating a new virtual, digital virtual twin. And the last but not the least is about productization 2 is about to reusing the components and automate the product templates. So when I bring information about this analyzation of the model interface, so how, as this interface are standardized, you can connect them in different ways. That's important. And you can even make the connections in a generative way. So comparison with a car, we can compare a car, we can call a car that's a component made of bespoke components. You have a car, the chassis of the car will be the same, but you can change the optionals, you can change some parts of the internal of the car. Maybe the engine you can change a little bit, but not too much because you have to fit that chassis. When you think about a building, when you think about a house, we can think differently. As we have these models with these connections analyzed, we can make it in very different, connect them in very different ways. So we say that the building is a bespoke assembly of standard components. You're not standardizing the building, not standardizing the house. You standardize the components and you can make a lot of different layouts of the house or all of different buildings with those components that you standardized before. So this is an example of a generative model. So you have the models and the design. As you change the design, the models adapt themselves automatically to the new shape. Here the models that are standardized, the connections and the structure, and so here another example. So you do a sketch of the building. You have the models already standardized, everything, and you just choose you adapt the design. You adapt itself to the models. The models you adapt to the design. In the end, you have the building with those models that was standardized, everything. So to illustrate this productization, I told you what a few items about what is productization, but why we are proposing productization. So the first thing we have to think is about a greater sustainability in the production. So the production significantly reduce solid waste generation in the construction process by standardizing the design, the components, and utilizing prefabrication techniques. Organizations, you can optimize material usage, minimal waste, and promote sustainability. So this will lead you to cost savings in waste disposal and contributes to a greener and more consistent industry. The construction industry actually is the industry that has the higher level of emissions of. So we are talking about 39% of the industry, the construction industry. So with productization, we can reduce this. Another item that why we are proposing, why we are proposing the shift to productization is rapid delivery. When you have the standardized component and those modular buildings, so you can have faster project iterations. So you can streamline your construction projects and improve their resource allocation, as I showed you, and you can simulate and you can control the process better when in comparison with the actual model for construction. So all these prefabrication techniques, this enable this parallel activities construction, and this reduces the timeline, increase the overall productivity of the equipment and the resource. Another thing we are addressing here is the shortage of skilled workers. When you have standardized models, in the standardized process, the skilled workers are not so many required for the job. So we are reducing the high complex jobs on site and bringing to inside the factories and standardizing the process, standardizing the models, and this enables you to produce smoothly and minimize the reliance on specific skill sets and increase the industry capacity to deliver your projects on time and on budget. And the last but not the least, customization. Again, with those standardized models, you can customize your product. You are with your process standardized, your model is standardized, but your product at the end, you can customize with different ways. Of course, you have to have those standardized interface to have this customization being possible. Now I will call my colleague Arnaud to show you a customer case that is Texel Walls. Arnaud, do you want to share your screen?
Yes, thank you. I was just setting something. That's fine. Let me share my main screen. Should be okay. Share sound. I don't need sound. That's fine. Okay. So let me present you this customer case. Sorry, didn't have that. So this case, we did it for Bouygues construction. So it's a big construction industry in France. And they were working already with Texca, who is producing prefabricated panels in concrete panels for the Asia mostly. So they had that building in construction already started, where they started working with Texca to do a couple of internal partition walls. And they really needed to speed up the production and have mostly a better adaptability for the ongoing modifications, because the architect and the final customer, the final client of the building, is always adjusting a couple of things during the construction. So that's very challenging to adapt to those construction almost day to day. So the goal was to have something similar to a just-in-time production. It's not exactly that, because we still have some panels stocked on site, but they wanted to limit the stock on site and have a more precise delivery, basically. So the process, the as-is process, was basically getting the Revit model that is done by the architect. It's modified internally by Bouygues to add the construction information, do the drawings that they need for each story, for each floor, and send the drawings where they need Texca wall to Texca. Then Texca is doing the panel layout in 2D and sometimes doing some elevations, and send the drawing back to Bouygues. So it can take up to a week to update and have the new drawing if something is modified inside the building. So that's quite long, and then you need something faster. So on the right, what you can see is the result of a couple of meetings that the design manager of Bouygues did with Texca to capture their installation rules, most of their know-how. So basically on 3 pages, there was 1 page with only text explaining some of the gaps and how it's done, and 2 pages with drawings with the basic situation that we will find on almost any wall of the building where they are using the Texca panels. So based on that, that's what we had to digitize the process and get that panel, that Texca wall, as a digital model, as a digital product, so that at the end, Bouygues is able to productize the whole wall itself. So I will talk a little bit about that later, but the goal is that later on, Bouygues has the wall as a product, and you can choose on each wall what is the construction method of that wall. So based on that, we created a whole set of tools inside 3D Experience CATIA, so that they can take the Revit model basically and turn it into a construction model with Texca panels cut exactly as they need them to be. So this is the building. We are working mostly on the staircase. So as you can see here, it's a basic architectural model that is imported into CATIA. And we will change that. So it's not magic, obviously, it's just to show what happens. But at the end, we have the individual panels created. So that's the final result. And as we saw previously in other videos, we will do a small virtual tour of what is done. So we have doors like that. We have the stairs are not, they are prefabricated, but they are not textile walls. So that's the result. And on the right, we have the Revit model of what we need. On the left, we have CATIA. And one of the challenges we had was to be able to track the modifications. That's one of the big problems because the Revit model is updated, it's revised, there are new revisions, and we needed to track that in CATIA as well. And hopefully, that's why we had the case basically, but Impararia developed a custom Revit converter for CATIA for 3D experience. And we are able to map some of the attributes from Revit to the attributes of CATIA. So it allows us to take those custom attributes where we have all the information needed, like the revision, the production zone, if it's repeatable, so from level 17 to 34, for instance. So a couple of things like that, the story as well, the level, and we get them into CATIA. It's not needed for the design itself, but it's needed for the tracking in time and the modifications. And one of the key in 3D experience is also the management of the life cycle. It's a PLM, it's a product life cycle management. So we need that information. And as I said, once we have that, we get all the attributes. We can recompute a couple of things when it's dimensions. And we created a set of tools that are located in chapters in a catalog. So the user will take the tool he needs, use the geometric inputs, and this will generate, in this case, the panels. And we'll see that. So you have a couple of parameters that you can change to adapt to the situation. And we also have embedded rules. So for instance, here we generate the lintels. So it's not all vertical panels. We have to generate one horizontal panel and then vertical panels above. And in this case, we don't have the length to put the panels like we want, because it would generate a panel that is too small. So that's one of the rules we had. We can't generate panels less than 20 centimeters long. So we have this, and we have a question. So do we adjust the first panel automatically? So we shorten the first panel, and so that the last one is at least 200 millimeters, or do we do something else? Because there are other solutions. So all these tools were developed, and we have, we will see that it will also generate the impacts from these panels to the panels on the side. And a few minutes later, we will see the final results with the material. So we have that horizontal panel that is creating a cut in the vertical panel with gaps that we defined. And almost everything is automatically created. And we can then generate a full bill of material of that. And we generate that in an Excel file because we can add a lot more information. We can export all the dimensions, of course, but also the information from Revit, because we get all those attributes, we are able to see them in Excel. And the other things, Tiago was speaking about that with the reality of a project. So we can go on site, measure what was actually built for the slabs, for instance, and we know that there are always some small differences between the original 3D model and the construction site. So they are able to measure that on site, go back to the 3D model here of the panels that are not already produced, and send this information back to the 3D model so that the model is actually designed as it is constructed. And then there are a couple of informations for delivery and things like that. So we also have obviously the the production drawings, installation drawings with all the gaps and what is needed. And for the whole process, they win, like, I think it's they are 80% faster to generate those drawings. And then Texca will review the drawings before launching production and going on site to install everything. So you can see here the virtual twin and the construction site on the right. And the most important thing for Bouygues at this time was this. The photo on the right is the delivery of panels pre-cut in the factory and on pallets exactly where they need them. So that was very important because previously what they were doing was just delivering the full-size panels. So they are 4 meters long. And they had to put that somewhere on site, then cut them directly on site as well. And finally, place them, go in the building, in the story where they has to be installed, where they have to be installed. And that will take some time. So the benefits here, you can see the customer story on the Dassault Systèmes website, where you'll find that. So they are 80% faster in the wall design itself, 50% faster in the installation, and they reduce waste material as well because everything is pre-cut in the factory. Sorry, there's the bug here. So that's really what was interesting, all those figures, and basically in the overall process time, design and installation, it's like 30% gained. So that's the benefits of the productization, in fact, of having this object as a virtual product. So based on that, as I told you, Bouygues now is productizing basically the wall itself with its construction mode. So we are now able, we are working and still working with Bouygues for this. So we are able to do walls with Texca panels or any other similar kind of panel. It can be Texca, it can be someone else in the world. And even if the panels are slightly different, basically we know that the rules will mostly be the same if it's the same kind of panel in concrete like that. So we can adapt our tool very quickly to change the original dimension, the default dimension and things like that. We are able to take a wall and transform it to a concrete wall, meaning we are working on the rebars, all the incorporations and the different connections for electricity, for plumbing, the doors, if you have doors inside the wall. You can do a drywall as well, and always having the wall as a product so that we can take the architectural model that is a plain wall, just a volume with no info, a couple of attributes, but that's it, and transform it to a construction wall, a to be constructed wall with all the production drawings. That's what we are trying to do currently, and it really changes the game. So as we saw from meeting with Texca, we were able to digitize the process and to transform that, the Revit model, to something manufacturable. And the challenges, we already talked about that. One of the challenges was a technical challenge to leverage the Revit data and attributes into 3D experience to follow the modifications and revisions. And the other one was to explain to Texca that it will also be beneficial for them, because basically we are taking a part of their job, that is, they were doing the drawings and now the drawings are done by Bouygues internally. So how it can be beneficial for them. So that there was a long talk about that, but basically they understood that doing everything in the factory, having fewer panels to deliver, being faster to install, all of this was really better for them because they can gain some margin. For instance, they will produce a better quality. So it's also how do you say that? And I don't know if Tiago, you know, it's a showcase of what they can do and how fast and accurate they can produce panels. So it's really interesting for them as well. And they were really willing to help, and they were reviewing the drawings, and they could do the reviews with the 3D model instead of only 2D drawings. So it was also faster and easier for them to point out the small problems if a gap is wrong or whatever. So it was really a win-win situation for everyone.
Arnaud,
yeah,
just excuse me, let me make a comment here.
Yeah, go ahead.
So a few important things that I would like to highlight when you are talking. So for example, when I was talking about the walls, the panels. So the panels now are a digital product, and they have all the specification, and they can buy this product for others suppliers too. So it's a standard model. It can happen with every model, and maybe it will happen with other products. We will have different suppliers from the same model. So as if you think in a car industry, for example, you can have different suppliers for the same part of the car because everything is digital and everything is very well precise and in the digital twin of the car. So and you just assemble the car in your factory and you deliver the car. So, but again, you have all these models blocks all digitalized and with the interface very well defined and standardized. This is on point. So now they can do this in the factory, and they can have all the panels and the walls ready to deliver on the field. And another aspect that I would like to bring is about not the product but the process itself. So as we see, if you go to the website of Texa, you see that they are with the process becomes a product, because they are still selling the process of construction these walls. So not only the model, but the process itself became something that they became a showcase that they are selling this for other clients. So we have this process that gives you more in less time. It gives you more quality and reliability and everything. So with this process, they are changing their own process because of this. So again, this is not about the product itself, it's about the process and the standardization of the models. Okay.
Exactly. And so yeah, you told everything. So yeah, one of the important point is also that now Bouygues has this technology for us as well, for them as well in the platform, so they can also reuse that on any other building. If they are building something else in Thailand or whatever in Asia, they can call Texca and do that again and adapt to any other situation, and can be even in Europe or whatever. That's really important. The fact that once it's digitalized, you can reuse it whenever you want and adapt to almost any situation. And the next slide is kind of personal proud, but that's the best feedback I could have from our customer. It's a screenshot from the platform. So in 3D experience, you have a lot of tools. One of the tools that is really useful are the communities. It's like an internal Facebook, if you like. So we exchange here. We can do posts, ask questions, and there are different kind of things. And here you have the first feedback. And as he said, usually Texca delivers the panels. They are like 4 meters long, and they cut it on site. And they started level 18, which was the first we did digitally. And for the first time, the panels were delivered at the correct height. And that's the photo you saw previously. And so he was really, really happy with that. And for me as a consultant, I'm also very proud that the customer really saw the use of that. And the other thing is that this guy wasn't using CATIA before the project, and he was really working with us and supporting us, and he was doing the work himself. So he's the head of the design office for Bouygues in Thailand for this building. And basically he took CATIA, I trained him, and in 3 months, we were starting building the tools together, and he was using the tools, doing the things himself. And that's also what helped us move forward and have something that is usable by almost any user. Later on, he trained one of his guys in the design office, and it took him, I don't know, a month to be I can't find my word, to be used to the tool itself and to be autonomous to do all the future stories by himself. So that's that was really interesting, and they really went faster with the design process here. Oh, what's this one? Well, there was something wrong with the PowerPoint, sorry. Tiago, I think you can take it's back to you now.
Okay, let me share my screen again. So thank you, Arnaud, for the explanations. I see. Maybe for you guys, this user case specifically, you work with modular home building, and you can think, okay, but we don't build buildings, but you can think about not only about the product itself, but the process and everything that comes with this. So this construction is one client that we are working now, and we did this awesome development for them, and we are still doing. And how we can add this to your business? So how Impararia and Dassault Systems can add value to your business with this concept of productization? As I told you in the beginning, we can integrate all the tools, CATIA, Revit, SolidWorks, and Bentley, even Inventor and GIS or 3D scanning document. We can make automations, consuming information about everything, every information you have, putting everything in this digital world. Even make those connections between the softwares. Getting the attributes and everything, and even enforce the standards, because we are very hard on the industry standards, and so we can do this add this value for your business. So, and we can analyze your business, and as business consultants, we can analyze your business and make very specific and customized bring practice to you for your business that will enforce them, and will make you product more standardized, your models more standardized, and your product more flexible. So we can make this and make the data accessible for all your project teams, for all your product team, for all the team you need in your company. How are you going to use this? You're going to use this through the 3D experience platform. I will show a video from you now that explains a little bit the mechanical of the platform, the benefit, and the features that you can use. The video doesn't have sound, so I'm just gonna send off, make some voiceover. So in the beginning there was specification research, and now we are working on this issue. So we have the issue component. You have the important thing is to have all the information. As Arnaud was telling, the platform allows you to have everything in one single point of truth. So you don't have different files in different folders or different systems or different databases. You can have everything integrated here, from the planning, from the product life cycle, from the project management, from the 3D model and everything, even the design you can do directly on the platform. You can add your workflows, your approval documents, your approval gates. And this example is an automatic bomb. And this example is when you can create even the instruction for the guys that will build the panels. And everything is connected. It's not a different software or a different database. When you change in one part, of course, you have the rights to change or not. But when you have the right to change, you change in one design, you change everything. It change for the supply chain, you change for the design, and for the people that you're gonna build the assembly, everything. And everyone in every, this is a cloud platform, so you can access from everywhere. See, again, this is an example of the small models that can build one product, even from those very detailed documents. You can bring to the site. You can everything you can do in the platform. As you make the project, the bill of materials automatically generated too, because again, everything is connected. So now you're gonna integrate the models. You can automate this installation with rules and with automated design. So you reduce time in design. And you have, as we had the models, you have the flexibility to change them too. So with the productization, so you increase your delivery capacity again. And I have a few benefits that we bring for you in the next slide. So sustainability, we reduce raw material consumption and waste by 5 to 20%, depending on the kind of product. You can reduce your on-site labor by 20 to 40%, addressing the skill labor shortage, because you will have process standardized, you have the model standardized, so you can bring to build the off-site construction. But not only that, you can make the standard process and and you can get the knowledge from the manufacturing guys, from manufacturing quality of control and everything to make your process more reliable and more clean. The engineering time, as we can use generic design and you have the standard models, you reduce your engineering time by 50%. And you get, but it doesn't mean that you have less option. In the opposite, you can build different layouts, different products with the same models, and the cost by 20%. Even the quality of the product, every product you build is a new product, but you get experience from the previous one. When you think about a project, every project, the definition of projects is exactly that. As a project is something that you put your effort, your resource to build something new. So every project is different. And when you comes to the productization, you try to make your process of building the product as standardized as possible. And you have different products too, but the control, the management, the supply chain, everything is the same, not change. Just change this where you're gonna install the house or the building, and the product at the end, in the end, but the process of construction is the same. Now we have a few minutes for questions. If everyone has questions, feel free to include in the chat.
Yep, you can go ahead and go and write it in chat. If you want to unmute yourself, feel free to do whatever you like.
Yeah, too. I think we don't have questions here.
Sometimes it takes a minute, but I don't know if no one has any questions. Yeah, and like I guess we can go ahead and move on. If someone has a question, we can feel free to type
yeah,
in.
Yeah, and we will leave our emails too. No contact. Feel free to contact us.
Of course.
So as takeaways for this presentation, I should bring that. So we showed you that construction industry is facing extreme demand for speed, sustainability, and customization. And we have the only way to meet this demand is to break off the constraints to the prefabricated and subcontractor coordinator mentalities. So doing the same way, we are not going to reduce, we are not going to improve. We have to do a new way. And coming from the product lifecycle management, we see that we have a lot of improvements to make in our process. So the productization drives more value and offers more scalability and customization. Imagine that the factories, you can have big factories to just escalate the production, automate and control more and more, to have the process in your hand, to have the process more controlled, and less the less skilled workers working on it. So as happens today with few industries, we have everything automated and we have no people in the factories. We just have few people to control everything, but almost everything is automated. And I know a few companies that are already doing this for modular homes. There are a few companies that are producing robots to build the walls, to assemble everything. So it's a matter of time. That brings me the third item is this because the forward-thinking business leaders are already adjusting their business to this virtualized process, digital deliverables, and off-cycle product management. So what means off-cycle product management? Exactly what I told them before. Take the product out of the project, because the process of product management is more controlled than the process of project management. And the 3D experience, as I showed you, can offer you the functionality necessary to support the construction of virtual twins, the productization, and the integration-ready models. We can integrate everything. And Impararia and Dassault Systems, I think, are the right partners to make it happen for your business, with our experience in the PLM, our experience in AEC industry, with our experience in development, integration, and with our research and development team, we can add value to your business in a higher quality, in a fast pace too. I would like to thank you all for your time. I'm sharing the contacts, so we can go to Impararia website, even LinkedIn. We have a lot of posts about technologies we are developing on LinkedIn, and our phone number too. So feel free to contact us if you are interested in something that we are talking on this webinar. And thank you.
Great. Well, thank you so much, Tiago, Arnaud, Karan, everyone. Thank you so much for this presentation. Yeah, we have it recorded, so we'll go ahead and see if we can get that out to everyone, and if you'd like. But yeah, thanks again for everything. If you have any last words. Oh, it looks like, yep.
It's just me. putting the link that is
Sure.
in the presentation. It will be easier
Oh,
just to click on
awesome.
the link here.
Cool. And I can go ahead. What I'll do actually, save that link real quick. I will go ahead and submit, like just send that out to everyone who registered in our little chat. So yeah, they'll have that there as well.
Okay, thank you.
Awesome. Well, if that's it,
Thank you.
yeah, thank you so much, guys, for presenting. I loved watching it. So if and everyone else, have a great day.
Yeah, you
Thank
too.
you.
Thank you. Thank you.
Thank you. Bye.
Yeah. Bye.